Hi, I'm Alex. I'm going to be talking to you about the gems of the Python standard library. Sort of what this talk is about is I have this belief that there's a lot of hidden gems of the Python standard library that people are just not really taking advantage of or possibly just don't know exist. And so I sort of wanted to explore that and actually expose you to sort of what Python standard library actually has to offer you. First, just a little bit about me. I'm currently a student at the University of Pittsburgh studying computer science and statistics. I'm also, at the moment, a software engineering intern at Uber ATG, where we work on autonomous cars, and I get to spend most of my day just coding in Python. But on the side, I work on a lot of side projects, and they all tend to devolve into me using Python because it's the most easy language for me to use, and it basically solves most of my problems. But through sort of doing these side projects, I started to learn about things that existed in the standard library, and I actually really started to use them more and more as I keep progressing through each different project that I come up with. And so this is sort of where this talk is actually kind of born from. And let's just take a deep dive into like some of these sort of libraries that exist. Well, not maybe a deep dive, but at least a high level view so that you can get some perspective and then take a deeper dive for yourself. So starting off under data types in the Python docs, there is one library called Enum that's actually fairly simple. It's just enumeration, and we can look at a simple example of this where we're creating an enumeration for colors. So we have red, green, and blue. In this case, we're going to assign red to 1, green to 2, blue to 3. If we say color.red, that's basically equivalent to 1, and even more interesting is that the enumeration, in this case color, is an iterable, so we can actually iterate through it. And there's actually a lot more sort of like functionality and features to it. But the ones I'm going to sort of expose is that there's other things in enum, including auto, which will auto assign the values. And so in our case, 1, 2, and 3 didn't mean anything. Sometimes it does have meaning, but in our case it didn't. We could have used auto and just called it every single time, and it would have taken care of assigning for us. There's also an interesting sort of other sort of object they have called flag, which instead does enumeration slightly differently. And in this example, we have red, green, and blue, but also white, which is an ORing of the values of red, blue, and green. And if we look at the sort of, if we just iterate through it, we're starting to notice what it's doing. It's doing like bitwise operations. And so there's definitely some other interesting things you can do with that because they're more like bitwise bit flags. The other sort of interesting thing under data types is bisect, which is just binary search. I recommend you just take a look into this yourself, but from a simple view, if you have a sorted list, and it's very long and you need to find values in there, bisect is going to be the fastest way to do it because it'll easily look at the middle and it will know how to sort of slowly bisect where you need to search down further and further. The next one I'm going to get into is super interesting, and I don't see this use case, I don't see this used a lot, and it's under text processing services. It's called difflib. It's a helper for computing deltas. Let's see like how this kind of works. So in this case, I have two sequences. I have sequence 1 and sequence 2. The first 3 elements are different, but the last one are the same. And let's see sort of some of the things that difflib provides. So context diff, in this case, shows what is different and what is the same really fast. But they also have other ones such as unified diff, which actually sort of is more closer to like how you look at a git diff. But there's also a further sort of granularity of detail where there's also ndiff, which will show you very specific changes. For example, the first element are 2 different words, but the second element are just words that were just 1 letter apart, and it will point out directly which letter it is. Really kind of more interesting is ndiff. If you hold on to it, you can actually restore back to either the first sequence or the second sequence. This is a kind of a weird feature that they have, but it does exist. And sort of the last thing I'll expose you to in difflib is get close matches where you put in give it a string, give it a list of sort of known strings, and it will figure out which one you're trying to go for as close as possible. And if you see an example, you can see it's we didn't really spell apple correctly, and it thought it's either apple or ape. And there's a lot more to difflib. I'm just sort of scratching the surface, and honestly, there's some kind of neat debugging or like helping like use cases that you can immediately take from it for free. The next one is under file and directory access. This is pathlib. If you've not heard about it yet, it's amazing. Dealing with paths in Python before were just sort of a headache and a nightmare, especially with os.path. It looked very ugly in the code, and you'd have to potentially import other things to get sort of what you're trying to go for. Pathlib does this away with this nice object-oriented approach. So looking at a simple example, we can easily import path. And I'm showing a basic way of, okay, let's do the current working directory. And cool, we now have that path. We can also do it for absolute paths. That's also a thing. Notice how it's returning a Windows path. It actually will turn also a POSIX path for macOS and Linux. So it actually keeps very OS agnostic, and it will all occur once the path is instantiated. And sort of some of the useful things that we can actually now do with this is, for example, for the we can, append to that path using the divide operator, which is very nice and intuitive. We can also ask things like, hey, does this exist? And if, for example, in this case, this output directory doesn't exist, let's make the directory. And we can also then ask, hey, does it exist? Is it directory? We can also do things on, so let's in this case, let's try to create a file. So we're going to append onto this output directory path. And we can actually call now .open on that file with the right flag, write some text. And I can even say afterwards, hey, is this a file? And it's like, yep, it exists, and it's a file. There's other things that are built in. For example, globe is built in, so I can actually say on the output directory, hey, give me all of the text files in there. And these are just some of the things, like it's really helpful. The API is very clean, and it has a lot of things built in, and honestly, it will make your life easier with paths. The next one is under concurrent execution. It's sched, which is just a very simple event scheduler. Sort of seeing how this looks. To make it, you just make an instance of the scheduler, make your function, so in case I made do action, and then you add on to the queue by using enter. Enter takes in the basic form 3 arguments, time, priority, and the function. You can also add on the arguments if you need to change that up. And in this case, so we use enter to sort of add it on to this queue, and I can even show you, hey, look, I did add it onto the queue. And then to get this scheduler to run, you just say .run. And we can see in this case, it waited a certain amount of time, 5 seconds for the first one, and then execute it, and then wait another 5 seconds and execute the next 2. And so the last sort of group is going to be internet protocols and support. Web browser, super easy and simple. Import web browser. You can easily open just directly on your browser, open a new, like window of Chrome, or open a new Chrome tab really easily just by using web browser. There's a lot more details to it. For example, like you can make it specific to open like Mozilla, Firefox, but for most people's use cases, open works. And then the other one would be just UUID. If you need some unique, universally unique identifier, this is probably the easiest way of doing it. It has all the different versions of it. I recommend you just look through documentation. Simplest one for people to use is UUID 1 or 4. 4 is random, 1 is based upon your system. With this ID, you can easily get the string of it, or on this UUID object, you can ask for the int and get a specific int. There's a lot more. There's like decimal and fractions exist, statistics stuff exists in there. There's like priority, like min priority queues using heap, and there's also copy. There's a lot more that I encourage you to explore, and these are just a few more examples. But I hope like this sort of gives you a little perspective of what actually exists inside the Python standard library. And I hope you actually all found something useful from this. All the code from this presentation is linked at this link wherever it is around me. And I also link to where you can find all the documentation for all the libraries I mentioned, so you can actually explore further.